This is Ham College, episode 12 for December 31st, 2015. This episode of Ham College is brought to you by ICOM, helping you make those long holiday travels more fun, and by hamstudy.org, a great place to study for your amateur license exam. Hi, and welcome to another episode of Ham College. I'm George.
I'm Tommy.
This is number 12.
Oh, a dozen.
An even dozen.
Yeah.
Well, baker's dozen, because we had one extra one. That was this time last year, I guess. Did we do that? It was, I think, in the end of November, wasn't it?
When we did the pilot?
Yeah,
around the end of November, 1st of December.
Well, we're glad y'all could join us for a rare Wednesday night edition of Ham College. Hey, we had the evening free, and looks like a lot of you did, judging by the chat room and the live stream there, so glad to have y'all around with us. You know, whenever we're doing a live show, we like to have the chat room going along at the same time. You can join us over here, especially those of you who are watching on YouTube. The chat window there on YouTube, we're not able to watch it and watch the one listed on the screen here at the same time, so join us at AmateurLogic.TV/chat.
Yeah, participate in the fun. There are quite a few people in there already, and I keep seeing more and more coming into the chat room.
Yep.
So.
Oh, looks like Donald Trump is back with us this time around.
Awesome.
Yeah. You know, he's a big fan of both the shows.
Yeah, he's going to make ham radio great again.
Is he?
Yeah.
Cool. What did we talk about last month, Tommy?
Last month we had a pretty good discussion on how to choose your first radio.
We did.
And there you go. Just pick from any one of those and you'll be good to go.
It's just kind of like rolling the dice, huh?
No, we gave some criteria, some things to consider when you're looking at your first one.
Yeah. And one of the biggest things I would say is, you know, talk to some of your friends around, get a little feedback from them. Mm-hmm. You know, you might have somebody close to you that happens to have the radio that you're interested in. Yeah,
that having somebody with the same equipment and familiarity with it kind of goes a long ways in breaking that the newness.
Yeah, especially when you're a new ham, it's a good thing to have the same kind of radio as somebody else, because you can get some help programming it. Yeah. We're going to talk just a little bit about that tonight. We're not so much on how to program it, but because they're all going to be different. But a few of the things you will want to.
Some reasons why you do certain things.
Yeah.
That should be good. It's good information.
Well, speaking of that, what is tonight's topic going to be?
Tonight, the topic is repeaters.
It is.
Yeah. So, I mean, when I got my ticket, I was anxious to get on the repeaters. I already did the research, had the repeater list already printed out, had to type it in back then, had typed up and printed out, and I was ready to go, waiting on my ticket and my radio to come in.
I have been waiting, I think I listened to the repeaters and a lot of Simplex for at least a month before I ever talked, because back when you and I got licensed, there was about a month wait between when you got your test taken and you passed and you received your license in the mail.
Well, it sure was.
You couldn't transmit until you actually had that paper in hand.
I remember the day my ticket came in the mail. I already had my radio, just like you got yours before yours came in. It was up. I lived in an apartment. And I remember walking down to the mailbox, and that ticket was in there, and I just about ran all the way back to get the radio when that ticket was in. And I got the radio, and I was scared to death to talk on it at that point. So
I think that's kind of a common thing.
Yeah.
You know, so we're going to recommend listen first. If we're going to talk about repeaters, I guess the first thing we really ought to talk about is not a repeater, but simplex.
Yeah.
That means if you and I are going to sit here and talk back and forth, we only need one frequency to do that on.
Yeah, absolutely.
And especially if we're close enough to each other that we can do it. As a matter of fact, we don't even need a frequency right now. We can
Just audio frequency.
yeah, but I mean, so we'll only need one frequency, and typically that would be what we'd call simplex. Here's a typical simplex frequency right here. This is what is that frequency famous for, Tom?
That's the national call-in frequency for 2 meters.
It is. So let's see. I guess you'll be the guy with the beard there.
Yeah, that'll work.
And I'll
You'll
be the other
guy with
guy.
the bow tie. Where's your bow tie?
I left it. So if I'm going to talk to Tommy, key up my radio, and I'm sending out a signal there on 146.52 megahertz. When I'm through, I let off that push to talk button, and then Tommy can press his, and bam, he's talking on the same
Voila.
frequency.
Just like magic.
Just like magic. And now I can hear him. So we're both using the same frequency. So only one of us can talk there at a time, and then we've got to wait for the other one to unkey before he would be able to hear us. So that's what we mean when we say simplex. It's simple communication, just using a single frequency.
One frequency.
One direction at a time. Now, beyond that, there's another mode, sort of like simplex. It only involves the two radios that are being used there, and that's called full duplex. And what full duplex is, you've got two different frequencies. You can see when Tommy's talking to me there, he's on 146.52. I'm talking back to him on a UHF frequency. I'm on 445 megahertz there. And this is sort of like a telephone. We can both hear and talk at the same time.
Yeah, yeah, you sure can. If you have a dual band, dual watch radio, that can monitor at the same time it's transmitted. So
Yeah.
that's a little bit of a hardware specific thing, but yep.
Yeah, and here we're showing doing it with two different bands because that would be the easiest way. You don't see a lot of full duplex communication, but it is possible, and it's just another mode that you could use.
Yeah, I remember we tried that when I first got my ticket. Just kind of playing around.
It's pretty cool in a way because if somebody gets long-winded, you can tell them, hey, you're getting long-winded. You can break in on them, but if you're on simplex, that's not possible. A guy could sit there and,
yeah,
you really keep talking for a long time. But simplex only uses half the bandwidth because it's only the one frequency there. So
yeah. If you're in a congested area, you want to be careful with that.
yeah. Now, sometimes we might be in a situation, say, where I'm here and Tommy is way over there. And as a matter of fact, he's so far away, our radios can't hear each other. And in a case like that, we still want to talk. What do we do, Tommy?
Yeah, we're going to go to a repeater.
And here's a repeater right here. You're talking to me on 146.34, but my radio's, I've got it tuned to 146.94 because I'm on the 9.4 repeater. You would think, well, I wouldn't hear you because you're off on another frequency.
You would think.
But what's going on there is that repeater is a receiver and a transmitter. So the repeater is sitting there listening all the time on 146.34 megahertz. And whatever it hears, it rebroadcasts out here on 146.94 in this case.
Right.
So while you're talking, I'm listening on another frequency that's 600 kilohertz above where you are in this case. Doesn't have to be, and we'll talk more about that in a minute. When you're through talking, then I can talk back to you. And guess what? I'm going to do it on the same frequency you were using, 146.34, because the repeater is still sitting there. It's always listening to that frequency, and it's always transmitting out on what is typically known as a repeater frequency, 146.94, or whatever frequency you're using. When you say join me on the 146.94 repeater, you're talking about the one you're listening to.
Yeah, the output frequency of the repeater.
Right. When you go to talk, the repeater is going to pick you up. It's listening on a different frequency, and it's going to rebroadcast you on that particular frequency.
Right. It's that's a good diagram too, because I remember right after I got my ticket, it was a little bit unusual for me to the comprehension of how that works, how it actually listened on one frequency. When you transmit, you were transmitting on another one on the same radio, you know, set up there, and it's really without looking at the frequency, you really don't know.
Yeah. So what is our benefit here from using a repeater? Why would we even want to do that?
Well, typically a repeater is going to be, the antenna is going to be up on a tall building or on a tower or on a mountain, someplace that's got a lot greater coverage. So you can get one that's in the middle, or you know, actually the coverage area is great enough that we can both get into it and hear from it.
So well, if I'm sitting here on a handy-talkie and you may not can hear it directly, that 1,000-foot tower sitting over there can hear it just fine and transmit out a signal strong enough that you can pick it up where you are.
Absolutely.
So you take the little radio that, I don't know, maybe you could talk, 4 or 5 miles with it?
Something like that,
and then,
depending on the conditions.
Then, depending on what repeater you're talking on, maybe now you can talk 50 miles.
Oh, because usually on the right repeater.
Yep. So the repeater is really doing the heavy lifting there, and you're just, you know, you're kind of piggybacking on it.
Yeah. So what's the downside of using the repeater?
The downside of using the repeater is, well, it's using 2 frequencies because it's listening on one frequency and it's transmitting on another. More people are going to be able to hear you. That's not necessarily a downside, but...
Not a downside, but it's something to be aware of.
Yeah. And the repeaters are shared, you know. Anybody else who wants to use that repeater is going to have to wait their turn till the current conversation is
and that's
finished.
what I was thinking of when I asked what was the downside. It's a shared system, and so you don't want to just hog it, you know, hog all the time on it. So you got to be courteous about it.
Yeah, leave room for other people to talk to. Don't just take it up for your exclusive use. Although there are closed repeaters out there that were put up with the intention that only a small group of people is going to be on this one, and you got to be on our club or don't talk on it. Well, most repeaters are not that way.
Right.
There's only a few that way, and you can ask around locally and find out which ones are, you know, which one everybody's welcome on and which ones maybe not. You know, they have a club.
I believe in our area, I don't know of any that are closed.
No, I think everything here is, you know, wide open to anybody who wants to use it, and it's that way in most of the U.S. Another good thing about repeaters is I can talk here, and a lot of people can hear me all at the same time, which that could happen on Simplex, but the repeater's going to have much better coverage area than I've got, you know, just sitting here at home. And repeaters don't only benefit a handheld radio. I mean, if you've got a base radio, you know, your antennas, you may have a tall tower and you may not, but you can always use a repeater from your base station and get the advantage of, you know, having a strong signal.
Yeah, we've spent many an evening having a nice rag chew session with a bunch of us from several counties to the north, and some people right here around, and that we couldn't have normally, you know, talk to directly like that with Simplex. Now,
I've got a repeater here in my shack, and I know you do too, that you use all the time.
Yeah.
But it's not like the repeater we were talking about a moment ago. What is it?
Yeah, you talking about the crossband repeater?
Yeah.
That's where the radio monitors one or the other, actually monitors both bands, and whatever band receives a signal, it's going to actually transmit that audio out on the other band. So
in the case here, I've got my base station set up with 430 megahertz on say the UHF band and 146.40 on the VHF band. If it hears anybody talking on UHF, it's going to rebroadcast out the same thing on the VHF frequency there, and vice versa. So either one of us can talk. You can see in this case, I'm always staying on 430 megahertz there, which I'm not sure if that's a good frequency to be doing that on or not. I don't ever recall using that one.
Yeah, I'm thinking maybe not, but but it's good for demonstration purposes.
Yeah. So I just stay on that one frequency. Oops, went back too far. I just stay on that one frequency there on the UHF band, and you're over on the VHF band just using one frequency, and it's crossband because it picks it up on one band, transmits it out on the other. So why would you want to do it that way? What's the advantage over doing that as opposed to having that other repeater where both frequencies were like in the VHF band?
Well, it basically you get a lot of the same advantages as a regular repeater, because most of the time that's running on a base rig somewhere that's got a decent antenna, and maybe you're walking around with the handy talkie, in the shop, and you're at the house or something, and your radio's out in your ham shack, and you could still be just as accessible and talk to the same people.
I guess what I was trying to say is the difference between a repeater and a crossband repeater. A repeater is generally what's out there for public consumption. I mean, it's receiving on, say, on the 2 meter band, and it rebroadcasts it out or retransmits it, repeats it on another frequency on the VHF band. When we use crossband, it's using two different bands to do that. And the advantage of a regular repeater is that, hey, if they're on VHF, you only need a VHF radio. Yeah. If they're on UHF, you only need a UHF. With the crossband, you'd have to have a dual band radio, one that can, transmit on VHF and UHF, and hear and transmit both on both those frequencies. But the advantage is when you start trying to put a transmitter and a receiver both on the air at the same time, it takes a little bit of special combining, say, to put both of those on one antenna without them, interfering with each other.
Right. So
you have to use duplexers at a regular repeater site, which are generally, tall cans, yay big around, maybe about this tall, and they're tuned. There's a tuning stubs on them, and it takes several of those to make filters so that the transmit frequency does not interfere with the receive frequency. Because if you're transmitting and receiving on the same frequency, it doesn't work. I mean, it's feedback. It's like taking a microphone and putting it in front of a speaker, more or less. So we have to use two different frequencies for that, and the duplexers are able to separate those two so they can run over a single coax out to a single antenna. With the crossband, it doesn't take all of that. You can use a duplexer for that is much smaller. I mean, fits in the palm of your hand, and it'll combine VHF and UHF. Where if we were trying to do two VHF signals or two UHF signals, it's going to take a lot more filtering because those frequencies are so much closer together.
Right.
So, crossband, that's a good solution, and it's one we use here, like you say, taking your handy talkie, and I want to talk further with it, so I just crossband repeat through my base rig.
Yeah, it's handy. A lot of radios have that built in now.
And then there's one other type of, well, I guess you would say repeater, and that's, say, a linked repeater. And these are common now. They weren't very common back when you and I got licensed back in the 90s.
No, we had a few around here, but it wasn't mainly activated during storms.
Yeah, but now there's a lot more ways to link repeaters, and what that is looking at the picture there, Tommy is actually talking on one repeater somewhere, and I'm talking on another one somewhere else, and we don't have to know what frequency each other's on, really. The two repeaters are connected to each other, and they handle all of that, and they can be connected together over radios, over wire, or over an internet link like Echolink or D-Star or IRLP or System Fusion.
Yeah.
Or there's probably some more in there I didn't even think of. But so in the old days, if we had a linked repeater, then that meant one repeater here and one over there, and they're talking back and forth to each other with radios so that they can each share each other's coverage area. But now, with the internet, a lot of these repeaters are linked to each other, over the internet. Yeah. So it's not unusual that, we could go to a radio here, get on one of the repeaters and talk to, Peter down in Australia or somewhere, anywhere in the world. 20 years ago, that would have been pretty much unheard of
We've
on a
done
repeater.
that.
Oh yeah, we've done it a lot. Yeah. So a linked repeater, or repeaters, that would be more than one. That's another way a repeater could be used. And then there's one other type of repeater too that.
You mean there's more?
Yeah, and let me let you guess what that is. Oh, you're reading. I saw you.
I saw it pop up there. And I actually forgot about that one.
I figured you would. Yeah.
Simplex repeater.
Yep.
And that can be really annoying if you catch one on the air.
Yeah, it can also.
It can mess with your mind.
It can be kind of spooky. Yeah, that's happened to me before. And what that is you're using one frequency for everything, transmit and receive. So the repeater is actually just a radio that's sitting there, and it's listening on a particular frequency, and the whole time it's listening, it's recording. When it gets through with that recording, when it senses that you let off the push-to-talk button, then it turns around and it plays back and transmit out whatever it just heard. Mm-hmm. So if you sit there and you talk for 2 minutes solid, it's recording you for 2 minutes. When you let off, it plays it back.
Yeah. They had a guy, where you remember the guy, there was one on the Simplex channel that we used, and every now and then you'd hear that thing.
Yep. Years ago there was one, and you'd come on, you'd say your ID, and we didn't know the thing was there. And then all of a sudden you'd hear yourself say your ID back to you. At first I thought somebody was messing with me. They were recording me and playing it back, and then I realized, no, it's a Simplex repeater. What is the one redeeming point of them? Why would you even consider one of those?
You can build that fairly easily yourself, and you can run it off of one single band radio.
Yep.
One frequency, one real simple, inexpensive radio.
Yep. So it doesn't take a lot to do it. It could be set up pretty quick if you had the stuff to do it with.
I think you could probably build that pretty easily.
You could. You could today, especially with computers. Makes it a lot easier.
I sense a Raspberry Pi project, maybe.
I hadn't even thought about that. But yeah, that should be easy enough to do.
Should be real easy.
As long as you can determine that it's keyed up. Which, yeah, I could see you doing that.
I have to look into that.
Yep. Well, so there's a little lesson on repeaters there. There's a lot more to know. We're going to be talking a little more about some of the various subjects tonight as we go through the question pool here. But right now, why don't we take a break and get a message from ICOM, our sponsor here, and then come back and let's get into the questions and answers.
All right.
Over the hills and through the woods to Grandmother's house we go. For those long holiday trips, let your ICOM radio help you enjoy your travels. Take ICOM's IC7100 D-Star radio with you this season. This radio offers an angled control head and touchscreen for easy mobile operation, a large internal speaker for clear digital audio, and it's perfect for multiband and all-mode communications. Interested in easy hands-free operation while you hit the road? ICOM's analog IC2730A mobile and the digital ID5100A both feature optional Bluetooth capability, a large backlit screen for high-contrast viewing, and 50 watts output power on both VHF and UHF. For entry-level D-Star operation, check out the ID880H. Features include VHF, UHF dual-band functionality, one band at a time, good menu structure and easy programming, and fast multiple scanning for maximum reception. Looking for a compact, rugged, and user-friendly radio on 2 meters? The IC2300H has a large, bright alphanumeric display with 3 backlight options, oversized tuning dial for easy operation while on-road, and 65 watts of stable output power. Visit icomamerica.com/amateur for more information on ICOM's mobile radio selection. why don't we give away this ICOM cap you got here, and
Looks just as good walking up as you do when you're leaving.
boy, if you weren't careful, if you combed your hair just right.
Oh, no.
A Donald Trump trick there. Oh, sorry, Donald.
Yeah, he's in there. You better be careful.
I have the best answers. Well, I got them all. Okay, Tommy, who we're going to give this to?
Well,
We've done a drawing there. We've done a drawing.
we did do a drawing, and the lucky winner is Dan Huber, KN0MAP.
Congratulations, Dan.
Yeah, congratulations.
We're going to send you the cap and the t-shirt there, and we'll give away another pair there next month. If you'd like to win that, how can they do that, Tommy?
You can send an email to hamcollege@AmateurLogic.TV.
And we'll have another random drawing and pick out someone else next month. Let's get on into our first question here. Tommy, what do you think our questions are going to be on tonight?
I got a good hunch that it may be something to do with repeaters.
That's very observant
And
of
there's
you.
probably a good chance that we just covered a lot of that.
First question.
Okay. What type of amateur stations can automatically retransmit the signals of other amateur stations? A. Auxiliary, beacon, or earth stations.
B. Auxiliary, repeater, or space stations.
C. Beacon, repeater, or space stations.
Or D. Earth, repeater, or space stations. Okay, so this is mine to answer here. Somebody in the chat room said C, but let me go over these and see if that's the one I think or not. A. Auxiliary, beacons, or earth stations. Well, I know that's not the answer because a beacon is not a repeater at all.
Right.
It's just a transmitter sitting there sending a message, generally a call sign over and over. Just sort of be used as a marker or for someone to see if they can hear it.
Mm-hmm.
So it's not repeating anything. So we know it's not A. B. An auxiliary, repeater, or space stations. It could be that because an auxiliary would be rebroadcasting something else. Could be a repeater we know does, and a space station, say a satellite, could repeat. So I don't think that's probably it as B. C, well, that starts out with a beacon. So we've already said a beacon's not a repeater, so we know it's not that. And then D, an earth repeater or space station. An earth station, I think, could be any station on the earth. Typically, you'd think of it as talking to something in space, but that's not a repeater. So it's got to be B, Tommy. Auxiliary, repeater, or a space station.
I would agree with that.
And that's what most people are saying in the chat room. If you said C, but the B's have it.
The B's have it.
Okay. What type of amateur station simultaneously retransmits the signal of another amateur station on a different channel or channels? It's A, beacon station.
B, earth station.
C, a repeater station.
Or D, a message forwarding station. And this one's mine, and I've got a strange hunch that it's going to be C.
You think it's going to be C? Well, tell me your logic there.
Well, we just said a beacon station doesn't retransmit anything.
True.
An earth station is a station that's on the ground. Well, some, I guess, supposedly could, but that's not primarily the definition of it. Message forwarding station, that's not really a retransmit. That's passing data on.
Well,
I don't think that's considered repeating.
yeah. Yeah, you could see where it almost
more
is.
like a relay.
Yeah. But, well, we know a repeater is what retransmits. So, I mean, that's the best answer.
Got to be C.
Yeah, all right. That's what they're saying in the chat room there. So
Then it's got to be right.
there you
Chat
go.
room's always right.
Okay, on to the next one.
All right. Which of the following describes the common meaning of the term repeater offset? A. The distance between the repeater's transmit and receive antennas.
B. The time delay before the repeater timer resets.
C. The difference between the repeater's transmit and receive frequencies.
Or D. Matching the antenna impedance to the feed line impedance. Okay.
Yeah, that was interesting.
So this one's mine to answer. Which of the following describes the common meaning of the term repeater offset? The distance between a repeater's transmit and receive antenna. I guess that would be an offset, but it's not a repeater offset. The time delay before the repeater's timer resets. Nah, that's not it. C, the difference between the repeater's transmit and receive frequency. There's your answer right there, and that's what everybody in the chat room's saying. Or D, matching the antenna impedance to the feed line impedance. No, that's
I don't even know how that could be considered offset.
Nah. So there you go, the difference between the repeater's transmit and receive frequencies, just like we were talking earlier when we showed the slides there.
Yeah, well, we were listening on 146.94, but transmitting on 146.34.
Yep.
They offsets the 600 kilohertz.
Yep. All right, next one here. What is the most common repeater frequency? Huh?
I said, oops.
What,
Basically
what
just gave away the answer to this one just now when I was talking about the other one.
Oh. Yeah.
Okay.
What is the most common repeater frequency offset in the 2 meter band? A, plus 500 kilohertz.
B, plus or minus 600 kilohertz.
C, minus 500 kilohertz.
D, only plus 600 kilohertz. And this one's mine, and I obviously at least think I know the answer because I said something a while ago about it, but I don't know how you would reason the frequency out other than you just have to know that it's 600 kilohertz in the United States for the offset for
on the 2 meters.
For 2 meters. Yeah, and so 500 for A is not going to be right. B, plus or minus 600 kilohertz, that's the one that's going to be the answer. C is not going to be right because that's not 600, and D, it says only plus 600 kilohertz, and that's not going to be right. So it's going to be B, the plus or minus, and the plus or minus is actually going to, well, let's see. Okay.
Yeah. So the plus or minus, that should be a clue too.
Yeah, and that's going to be where the repeater frequency falls in the band.
Mm-hmm.
If you're at the high end of the band, you're not going to have a plus offset because 600 kilohertz might push you over the edge of the band.
Yep. Different parts of the band have a different, either positive or negative offset there. Yeah, we got the handy talkie there.
We do, if the battery's still up.
So let's look at that. We're talking about repeater offsets, and how can we tell what the offset is programmed into this radio?
Well, we can tell that we've got an offset because we have the minus right here. The ICOM radios have duplex.
Yep.
So this radio's working in duplex, and there's a minus offset. So when we transmit, the frequency is going to go down 600 kilohertz.
Well, let's show that.
Well, let me
let's go
ID to
say
be legal.
Transmit. And let's
in
prove
5Z&O testing.
All right, so you got the button push. It's on 144.85, and you let off, and it's listed on 145.45. And we didn't hear anything because we're in the metal building.
There's no signal getting out of this building.
Yep. So it receives on this frequency. When you transmit it, it transmits a minus 600 hertz from where we are, and that's what that minus
kilohertz.
Yep. That's what that minus is by the duplex there means.
Right. Have you got a repeater in here that's got a positive?
I don't know that I do.
One repeater in here.
There's more in there, but there's no. They're all negatives that are in there, I think.
There's a positive right there.
There we go.
What is the common repeater frequency offset in the 70 centimeter band? A, plus or minus 5 megahertz.
B, plus or minus 600 kilohertz.
C, minus 600 kilohertz.
Or D, plus 600 kilohertz. And
Yeah.
this is mine to answer.
I was that close to spilling the beans on that one.
You were. You were just all over it. I could see it coming there. All right, so I know it's going to be a plus or a minus. It can go either way.
Mm-hmm.
So that narrows it down. It's got to be A or B. B was correct for 2 meters. It was 600 kilohertz there
Yep.
for 2 meters. However, on UHF, those two frequencies are a lot farther apart. It's 5 megahertz plus or minus.
Mm-hmm.
And that's what, well, we did have a C in there, but no, the answer is going to be A, plus or minus 5 megahertz. Let's just prove that there by looking at.
I've often wondered why it's so much difference between the two. And if we transmit in 5Z0, 449.9, 444.9, so you can clearly see that it went up 5 megahertz when we transmitted.
You said you wondered why they were so much further apart on UHF.
Yeah.
So did you ever figure it out?
No. I never really bothered to look it up.
Yeah. I think it's because we got a lot more bandwidth on UHF. So we
Just give it some more separation.
yeah, we can have a little better separation on it. I'm not really sure of the official reason. I would think that sounds plausible.
Yeah, I'll buy that. That's good enough.
Yep. All right, well, that's about all we can say about that, so let's go to the next question.
Okay.
What is the term used to describe the use of sub-audible tone transmitted with normal voice audio to open the squelch of a receiver? A carrier squelch.
B, tone burst.
C, DTMF.
Or D, CTCSS.
Okay.
And I guess I got to answer this one.
I guess you do.
Okay, so carrier squelch. I'm not exactly sure what the definition of carrier squelch is.
That is like
but I know that's not it.
That's like a regular squelch that's sitting there, say, pretend
that's
it's looking
normal.
at your signal meter.
Normal, just this normal squelch. Okay, yep. And I did know what that is.
Mm-hmm. You just didn't know you knew what that
it's
was.
just past my bedtime. Okay, so that's not going to be it because there's no tone involved in that. Tone burst. That sounds like that could be plausible, but I think that's used mainly like over in Europe, in the UK, where they send out a tone. Like I think it's like 1750 hertz. Or
Yeah,
something.
I've forgotten what that tone was. But,
So as soon as you transmit it, it sends out that tone burst only when the carrier is at first initiated, and so I don't think that's it. DTMF, that's where you use like the pad on your telephone, and well, this one doesn't show it, but
yeah.
anyway, so that's not going to be it. It's going to be CTCSS. That's going to be the answer.
And what does that stand for?
That stands for, let me get my cheat note here. Continuous tone coded squelch system.
There you go.
Continuous tone coded squelch system.
Okay. And they say that it's sub-audible there. Actually, all those tones are audible. We don't normally hear them because the speakers are so small in a rig. But you will, if they've got the injection turned up real high, if they're running a lot of that signal, you'll notice a little hum or something that doesn't sound quite right.
Yeah.
Sometimes on a repeater, and that's what it is. The repeater is maybe transmitting that signal out. But generally, it's real low frequencies. We call it sub-audible, but they're all above 20 hertz, so they're all.
Yeah, and sometimes you can hear it worse depending on what the tone actually is, the frequency of it.
Yeah. Now, another term that you'll see used for that a lot is PL.
PL tone. Yeah, I think that stands for private line.
Private line, and it was one of the commercial two-way radio manufacturers, I think, used that, which essentially, it's just a way that you can have another squelch for a rig that doesn't respond to random stuff. Like if we're in a real noisy environment, I've got my radio tuned to a particular frequency. There could be just some garbage or harmonics generated around that every now and then is going to cause the squelch to break on my radio. It's not something I wanted to hear. It's just some random noise that happened to be around, or maybe somebody trying to reach a repeater that's way off. But by putting a specific tone in there, then we can tell that radio only open the squelch when you hear somebody transmitting with this tone. So you've narrowed it down. There could be other people on that frequency, but all you're going to hear is the ones that have added that tone.
Right. So that's for the receive side.
That's for the receive side, and I think we can.
But we're actually transmitting the tone here, so the repeater. That seemed to be.
Yeah, well, it actually could go either way.
Yeah, some radios. Yeah, if your radio supports it.
Yeah.
I think more of the modern ones do now have the receive and the tone encoder and the decoder. But used to, if you wanted to decode it, you had to buy an add-on board for a lot of the radios.
Yeah.
But you can see right here, this repeater has the tone enabled.
Okay. And so it says tone. Some other radios might say CTCSS, or maybe, I guess they could say PL.
Possibly. I don't remember seeing any, but I'm sure there are probably some out with it. And I just want to see, we go in there, repeater tone, 77 hertz tone for that one.
Okay. Yeah, and a lot of them in our area are using 77 hertz now, and then the ones that aren't, most of the others are using 100 hertz. But that's going to be different in different areas. And one reason for that is, we've got a limited number of frequencies, so maybe if we've got a repeater here on 145.45, covers this part of the state, there's another one in Alabama on that same frequency. And when the band conditions get such that, our signals go a little further, we kind of help out the situation by, say, each of these repeaters is listening for a different sub-audible tone. So only people intending to talk to the local one here are transmitting, say, the 77 hertz tone. So that's the only ones this repeater hears. The people over in Alabama that are maybe using, I don't know, 100 hertz tone, it doesn't hear them.
Right.
Or it doesn't open the squelch.
Right.
When they talk. So,
but if you have your 77 hertz tone and you actually break the squelch on the repeater by transmitting the tone, if that one transmits at the same time, it's still going to pick that up because the squelch has been broken on the repeater.
To an extent, yeah. Except for capture effect, like with FM, whichever signal is the strongest is the one that grabs the receiver. You can't typically hear two at the same time, but yeah, you could actually hear a little bit of that going on.
Which of the following common problems might cause you to be able to hear but not access a repeater even when transmitting with the proper offset? A, the repeater receiver may require an audio tone burst for access. B,
the repeater receiver may require a CTCSS tone for access.
C, the repeater receiver may require a DCS tone sequence for access.
Or D, all of these choices are correct. And let's see, this is mine to answer. So if I'm trying to talk on a repeater and I know I've got the offset set right, say if I'm on 2 meters and I've got it for plus 600 kilohertz and that's what it's supposed to be and it still doesn't hear me, I probably, in most cases, I don't have the CTCSS tone turned on or set to the right frequency. But if you're in an area where they're using a tone burst, where you key up the mic, it sends a tone burst, then you can start talking. If that, if the repeater's listening for that, which I've never heard one here that uses that, that could be another thing that I might not have right. Kind of unlikely, like you say in the U.S. C, the repeater receiver may require a DCS tone sequence for access. That is possible too. I'm not sure what that stands for.
Digital coded squelch.
Digital coded squelch. That means it sends, you key up the radio, it sends a few tones at the beginning of every transmission, and that's how the receiver knows to
essentially
unsquelch.
like a password.
It's sort of like a password. So I'm going to have to say it's going to be D, Tommy, all of the above.
I think that's right.
And that's what most of them are saying there in the chat room, and
All right.
we were all correct.
All right, everybody pat yourselves on the back.
Yeah, doing pretty good on receivers, or repeaters so far.
Yep.
Yep. So the next one here.
This is good stuff, too. This is practical stuff that you'll use when you get your ticket.
Oh, yeah. What method of call sign identification is required for a station transmitting phone signals? A, send the call sign followed by the indicator RPT.
B, send the call sign using CW or phone emission.
C, send the call sign followed by the indicator R.
Or D, send the call sign using only phone emission.
What do you think?
Well, if you're transmitting phone signals, when they say send the call sign followed by the indicator RPT, no.
Never heard of that.
I've never heard anybody do that. Send the call sign using CW or phone emission, so that's Morse code or voice. And I think that's going to be your answer. All right, let's go through the rest of those. C, send the call sign followed by the indicator R. I've never heard anybody do that.
Although some repeaters will put an R after the call sign if they're doing a CWID. But I've never heard anybody talking and say...
You're right. Send the call sign using only phone emission. No, that's not right, because I do know CW is valid. So the answer's got to be B. Bravo.
Yeah, well, we were a little mix there in the chat room between the B's and the D's. Yeah. So let's see who's right, Tommy. I know what I think, and yeah, I agree with you. If you're talking voice, phone signal, you can ID with either CW or you can ID with voice. But there's another way that the rules or the question pool doesn't really take into consideration, isn't it?
Yeah, I think D-Star, some of the digital modes, there's a data packet that's sent along with that's got the ID in there. So that's FCC recognizes that as being legal, but I'm not sure that's actually considered phone. It may be considered data. I'm not sure how the FCC looks at that.
Yeah, but we do know that if you're talking on say a D-Star radio, your ID is programmed in there, and when you transmit, it's sending a digital ID while you're talking. So a lot of people won't do a voice ID. Right. On a D-Star radio, they rely on the radio.
And that is accepted by the FCC. It's perfectly legal. Although I still tend to do it voice ID anyway.
You know, I generally do too, and a lot of people do, but you don't have to.
Yeah. Nowadays, you don't really know if anybody's got you linked in going out over the air with something else too. So yeah, you're always legal if you do that.
Yeah.
What brief statement is often transmitted in place of CQ to indicate that you're listening on a repeater? A, the words hello test followed by your call sign.
B, your call sign.
C, the repeater call sign followed by your call sign.
Or D, the letters QSY followed by your call sign. Now, you hear us laughing a little bit in there, but that's because some of these seem kind of silly to us, these particular answers. And but if you don't know it, it's a good time. It's a good question. Yeah.
Although the A there seems kind of yeah.
But I have heard that before, I think, probably, or something similar to that. But yeah, what brief statement is often transmitted in place of CQ, indicating that you're listening to a repeater? Well, it's not hello test. B, your call sign. Well, that's what I'm going to say, and that's what everybody in the chat room is saying. That doesn't necessarily mean if I come on a repeater and I just say W5JDX, that doesn't necessarily mean anything except that, hey, I'm listening to the repeater. I just talked on it.
Mm-hmm.
Doesn't necessarily mean I'm waiting for somebody to answer, although there's a good chance that maybe I was hoping to strike up a conversation. But it does mean that I'm listening. C, the repeater call sign followed by your call sign. No. You don't have to say the repeater's call sign.
No.
And D, the letters QSY followed by your call sign. QSY means you're changing to another frequency. So...
Pretty sure nobody's going to answer you if you say that.
Yep. And you're not going to... And if you're leaving, you're not going to be listening to that frequency anymore.
That's why I'm not going to answer you if you say that.
So let's see. Is B your call sign? And I think, that's just about what everybody had there.
Yeah. Man, you nailed that one. It's almost like you've done that before.
I have ID'd before on a repeater before. And I was listening after I did it.
Did you?
Not while I was doing it, though.
Did you say hello test?
I didn't. I said hello test W5JDX QSY.
Time for refreshment. Refreshment. For your enjoyment, there's hot, fresh popcorn, tempting, delicious hot dogs, and so many kinds of ice cream. And, of course, sparkling, delicious, ice-cold Coca-Cola for everybody at the refreshment counter now. Remember, your favorite snack will taste especially good with world-famous ice-cold Coca-Cola.
Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebean, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam. Let's get back to the remaining questions here. Which of the following entities recommends transmit, receive channels, and other parameters for auxiliary and repeater stations? A, the Frequency Spectrum Manager.
B, Frequency Coordinator.
C, FCC Regional Field Office.
Or D, International Telecommunications Union. And this is mine, right?
Mm-hmm.
So I don't think it's going to be a Frequency Spectrum Manager. I've never heard of that position. And spectrum, that doesn't really seem to apply for a repeater channel. B, Frequency Coordinator. I think that's going to be the answer. C, FCC Regional Field Office. I don't think the FCC regulates those frequencies. I don't think they regulate those frequencies.
Well, they don't assign them, no.
Well, yeah, actually, yeah. Or D, the International Telecommunications Union. That's not going to be it either. I'm going with Frequency Coordinator, and that's my final answer.
Well, looks like that's what everybody's saying over in the chat room, so maybe you're right. And yes, you are. Frequency Coordinator. This is a side note, and this is primarily for repeaters we're talking about in auxiliary stations. But if you're going to put up a repeater, you need to find out who the frequency coordinator for your area is and work with them to assign a frequency for you to use, a frequency pair. If you can find a frequency pair on your own and you put a repeater on the air using them, the FCC is not going to come knocking on your door or anything like that. But if somebody else goes to the frequency coordinator and requests those same frequencies and gets them assigned, they'll get the frequency, even though you may have been on it longer. Yours was not coordinated, so it didn't. You really don't have any claim to the frequency.
Right.
And the coordinator's just there to kind of help us, work
make sure
together.
everything's all spaced out and we're not going to have interference.
Mm-hmm.
Who selects a frequency coordinator? A, the FCC Office of Spectrum Management and Coordination Policy.
B, the local chapter of the Office of National Council of Independent Frequency Coordinators.
C, amateur operators in a local or regional area whose stations are eligible to be auxiliary or repeater stations.
Or D, the FCC Regional Field Office. Well,
I'm glad you got this one.
yeah, I know the answer to it. I'm just trying to think of how to help you identify it. Well, the FCC doesn't appoint frequency coordinators, so we can knock out D there. The FCC Office of Spectrum Management and Coordination Policy, no. We've already said the FCC really doesn't get involved in that. B, the local chapter of the Office of National Council of Independent Frequency Coordinators. That would be the local chapter of ONCIOIFC. Anything that long can't be right. It's C. Amateur operators in a local or regional areas whose stations are eligible to be auxiliary or repeater stations. And that's what everybody was saying over in the chat room there is C. So we all got it right.
Way to go, chat room.
And that's all the repeater questions.
That's it.
That's it. We got 2 more questions left here, but that should give you a good idea about repeaters. Now, we didn't show you how to program that radio to put in an offset frequency or to put in a PL tone or a CTCSS tone, because they're all a little bit different. But those are 2 things to keep in mind. If you're going to operate a repeater, find out the frequency that it's supposed to be on. Find out the offset, so you know how to program your radio for a plus or a minus offset, so that when you go to transmit, it transmits on the correct frequency. And what's the other thing that is possibly going to need to be programmed? Doesn't necessarily have to be, but might be required by a repeater.
A CTCSS tone or a PL tone, if you want to call it that, which I tend to call it that, but that's probably not the best.
Yeah, and then a lot of people just call it a tone because it's what's used most of the time.
Right.
Well,
here's a good question for you before we move on. How do I know what repeaters are in my area, and what I need? How do I get that information to program my radio? That's
a good question. Well, the first thing I would do is try to find another ham in your area, someone who can, kind of help you get started. Sort of Elmer. He should have a list of repeaters. Back when you and I got licensed, that was the only way we could get that information, is by talking with other hams who knew the frequencies, or by buying a book called a repeater directory that I believe the ARRL has an edition of that. And then there might be 1 or 2 more out there that you could buy. There used to be, a number of them, and you'd go to the Hamfest and you'd buy a new repeater directory every few years because repeaters have changed. Well, now with the internet, you'll find them online. There's a lot of sites online to where you can look up repeater frequencies and the offsets and the tones.
There's apps for your phone. A lot of them are coordinated with the location now, so that can actually tell you the one that's physically closest to you. There's a lot of cool information now that we didn't have before.
Yep, yeah, there sure is. And some of the information that's on the internet might be a little out of date. Even in some of the repeater guides, it could be a little out of date. So if you're not finding it there, and you've gone through the offsets and you've gone through the PL tones, you're going to need to just find somebody in the area and ask them. Maybe the repeater's no longer there on that frequency.
Yeah, that's there's several in our area that are like that, that are still listed in directories that aren't on the air anymore.
Or it could be they've changed the PL tone. So, yeah, that's a good question. So we've got a couple of electronic questions now, just to kind of round off the evening here, Tommy.
Okay.
I'll read this first one here. What electrical component is used to connect or disconnect electrical circuits? A magnetron.
B, a switch.
C, a thermistor.
Or D, all of these choices are correct.
Well,
So this is mine.
this is yours.
Well, I don't think D, all of these choices are correct by any means. And a thermistor,
Do you know what that is?
I think it's like you can measure the temperature,
So,
with it.
yeah.
So I don't think that's
It's
it.
a resistor that changes value with temperature.
Okay. And I don't know what a magnetron is either. I think I saw that on the Transformers movie. Wasn't he the big guy with the red
Isn't that what's in your microwave?
magnetron? Yeah, it could be in there too. I hope they get him
Yeah.
out.
Before he melts.
The answer is going to be B, a switch.
Yep.
The
Connect and disconnect an electric circuit is going to be a switch.
What electrical component is used to protect other circuit components from current overloads? A, a fuse.
B, a capacitor.
C, an inductor.
Or D, all of these choices are correct. Let's just say the answer is A.
The simplest.
We already know that. So we'll just say a fuse. Okay, but let me just say if you really got a bad circuit, yeah, maybe a capacitor could end up protecting some of the other stuff in there when you blow it up.
Yeah.
But no, it's a fuse. And that's basically just like a little thin piece of wire that if you draw too much current from it, it gets too hot and it just burns in two.
Mm-hmm.
So I think probably most of this crowd knows what a fuse is. Everyone in the chat room did anyway.
Yeah, everyone in the chat room, but there's some people may not. But the answer is a fuse.
Okay. Well, that's our questions and answers for tonight. We appreciate you joining us. Before we go, let's mention our social networks. You know, there's places you can learn more about Amateur Logic and Ham College. We've got a Facebook group that's real active. It's where is it?
Facebook.com/groups/AmateurLogic.TV.
And we've also got a Google Plus community.
Yeah.
That's pretty active.
Yeah.
And you can follow us on Twitter, and that is
At AmateurLogic.
okay. I think that's all of them, isn't it?
That's pretty much it.
Yep.
We've got a Ham College group as well.
We
You know,
do.
this is the
We
Ham
do.
College show, but honestly, it's not very active. It's
Most of the people are on.
on both of them. But we try to post over there some, but
Yeah.
the majority of the activities over on the Amateur Logic group.
Yep. And we also want to mention the wiki, where you can get the show notes on episodes of Amateur Logic and Ham College.
Yep, and thanks to Dan and 9LVS for taking care of those for us.
Yep. That's at AmateurLogic.TV/wiki. And
Amateur Logic swag. And we now have Ham College swag.
we do.
So I copied, sort of did my best to copy the nice sweatshirts Mike and his wife sent us for Christmas. So we've got Ham College sweatshirts over there in the store now, and some Ham College t-shirts. So you can go to amateurlogic.spreadshirt.com and check those out if you're interested in any of those.
We appreciate y'all joining us tonight. We'll be back for another episode about this time next year in January.
But this time next month.
Next month. And we'll be back with another Amateur Logic in a couple of weeks.
Yeah, that'll be here before you know it.
We've got to get busy on that one.
Yeah, we do.
It's going to be like a whole new season, if that's when we start our seasons.
Do they ever end?
Not anymore.
It's just one big season.
Well, they used to end at the first of the summer for that 6-month summer break.
Yeah.
You know. And then we'd come back. All right. Happy New Year, everybody.
Happy New Year. Be safe, and we'll see you next time. 73.
73. Why don't we give away this ICOM cap you got here and a pulley folded ICOM t-shirt?
Fully folded.
Is that what I said?
Uh-huh.
Something like that. We didn't cover everything. As a matter of fact, we didn't even get that other camera set up over there that we might want. Well, before we go, let's just mention a couple of things. We've got some social networks out there where you can learn more about Amateur Logic.
You want to go back and mention those again when I'm not sticking my finger in my own eye?
Well, you made it to stick it in.
No, for some reason my eyes are burning.